In our problem, we have a population, and from this population, we select a sample, and from this sample is given a data one by one. Let's do a simulation. Remember, when we obtain my data from the entire population, we have a census. All of these numbers represent the measurement of one characteristic in all members of this population. Each point represents one member of the population. Let's do a simulation. Suppose that this population, I know that the mean is 100 and the standard deviation is 2. If I measure this characteristic in all members of the population and we plot in a number line all of these points according to its measurement, I know that 100 will be here. It's possible that when I plot all of these points in this number line, I will obtain something like this. The majority of these points will be located close to 100 because the mean is 100. This is a bell-shaped distribution, and the standard deviation of the distribution is equal to, and according to the empirical rule, within 3 standard deviations to the right and 3 standard deviations to the left of the mean, exactly 106 and 94, between these 2 points, we have approximately 99.7% of all measurement of this population, all of these numbers. Let's do a simulation here in StatCrunch. Here in StatCrunch, let's do a simulation, and the distribution will be normal, and we know that the mean is 100 because in simulation we know the parameter, and the standard deviation is 2. In this case, the seed is 12,641. I will explain later what it is. Let's use no decimals in my sample, and we are going to select from this population 30 observations. My sample consists in 30 observations. In this case, n is equal 30, and I am going to measure these 30 observations, and I am going to organize all of these observations in one table, here in one column. And let's compute. We have here 30 observations in this column. Normally in a StatCrunch, when it's given a problem, it's given the data, and beside the data you can find this icon, and the meaning of this icon, when you click this icon, you can send the data either to StatCrunch or to Excel. You can use these 2 software during your proctor test, and you can use it to show your work. I will teach you how can you use it. It's very important that you identify this little icon beside the data in all problems. We have selected 30 observations from the population. This population could have millions of items, and I selected only 30. These 30 observations were selected randomly from the population. How does this computer select this random sample of 30 observations? I will tell you how. First of all, to each member of this population, we are going to assign a number from 1 to whatever number, one number. For example, if this population consists in 1 million of items, then this one could be the number 230, and this other one could have the number 1323, whatever. We can list in the census each member of the population with its corresponding number and its measurement of the characteristic in which we are interested. Or we can plot all of these points in this number line according each measurement to obtain this pile, this normal distribution. If we select 30 from this pile, 30 observations from this pile, you will notice in this simulation that all of these numbers are between 94 and 106. 3 standard deviations above and below the mean. You can observe, if you look at all of these numbers are between 94 and 106. That is the empirical rule. What is the process that the computer and statistician use to select a random sample from the population? we use random numbers. This is a section of a table of random numbers. Here we have multiple columns of digits generated by a software. A software can fill all of these columns with digits between 0 to 9 to obtain multiple pages of random numbers. In this column, for example, we have 3, 4, 3A. A software can generate randomly this column with digit, any of these 10 digits, and so on. We can divide this column in group of 4 or 5, whatever, only for reference. And we can start at any point to obtain random numbers. Suppose that the population consists of 800 items. We use big case N, and from this population we want to select a sample size 20. We are going to name each item of this population with one number between 1 to 800, and after that we are going to start at any point in this table or any page of this table generated by the computer. For example, we can start here at this point, and that is the C that we were talking about at the beginning. The digit number 12,000 or the column number 12,000, whatever. Then from this point, we can take any direction, down, up, to the right, to the left, diagonal. In any direction, we can select 20 observation. And suppose that we are going to select this direction, down. Because the population have only 800 items, then we need only 3 columns, column 1, column 2, and column 3. Then these 3 columns. If the population had only 80 items, then we need only 2 columns to obtain my random numbers. Then in our example, my first selection will be 803, because in the population we have only 800 items, doesn't exist item with this number. So we skip this number and we continue with 27. Suppose that this is the item we assign the number 27. Then this will be part of our sample. The next will be the item 183, the next 493, and so on until we obtain 20 items. In this list, this item and this item will be skipped, and we are going to continue it with the next 3 columns, these next 3 columns. Then we are going to continue with this item, the item number 752, and we will continue it down in this way to obtain 20 observation or 30 observation or whatever number of observation. This is the most common way that a statistician and computer generate random samples. Then once you have collected your sample from the population and obtain your data from this sample that are the measurement for each member of the sample, then we can organize, we can summarize, we can analyze, and we can draw conclusion about the population using this sample. We can organize the data using a frequency table, and we have to go to a stat, table, frequency. My data is located in this column, compute, and we have our frequency table. Then we have 1 item 97, 4 98, 6 item 99, and so on. That is the frequency table. The minimum value is 97, the maximum value is 105. Most of the value actually are located between 98, 102. Also, we can obtain a histogram here in graph. Histogram, my data is located in this column, compute, and we have the histogram. Then in the histogram, you can observe that we have one item with a measurement of between 96 and 98. Between 104 and 106, we have 3 items, 1, 2, 3. Can you see? 3 items. Then the class with the highest number of observation is the class between 100 and 102. We have 11 observations in this class. Also, we can change the width of this class. In this histogram, the width of all classes is 2 units, but we can change the width to 1 unit. Here in option, the width is equal 1 unit. That is the histogram when we change the width. StatCrunch also gives me the summary of the most important statistic. We have to go to Stat, Summary, then my data is located in the column Normal 1, then Compute. These are the most important statistics. Then here we have the mean, the variance, standard deviation, standard error, I will explain this later in chapter 6, median, range, minimum value, maximum value, the first quartile, the third quartile, and the third quartile. The second quartile, remember, is the median. But be careful, pay attention. I will allow you to use StatCrunch and Excel in all tests, including the Proctor test. Then you can obtain the answer very easy, but you need to show your work. You need to use formulas to obtain all of these statistics. For example, if I request in this problem, show your work, you need to do the following step to obtain the mean, the standard deviation, and all of these statistics.